Go through a tutorial on one of the aspects of annular motion of the sun and its orbit, the Earth and its orbit around the sun, and that is that we experience seasons. Yeah, historically speaking, teaching this course for a while, this is one of the pieces of information that is the lowest probability of everyone grokking through to the end of the course. And I think it's nonetheless important that people understand what causes seasons, the difference between summer and winter. If we don't have a basic understanding of that, I find it doubtful that we'll have an understanding of how climate is changing and other issues beyond just the basic geometric effects that give rise to seasons, different locations on Earth. So we're going to go through the tutorial and hopefully it'll help catch the common misconceptions for the reasons for seasons. All right, part 1. Listed below are the distances in kilometers between the sun and the Earth for 4 months of the year. And then the drawing at right shows 4 different locations of Earth during its orbit around the sun. And the sun's not really showing very well, so let me sketch that in. So there's our happy sun. Note that for each location drawn, Earth is correctly shown with its rotation axis tilted at 23.5 degrees. So December, Earth sun distance 147.2 million, June 152 million, September 150.2 million, March 149 million kilometers. Alright, so let's go through some questions. Is the direction that Earth's axis is tilted changing as Earth orbits the sun? No, our rotation axis is fixed. All those lines are parallel to one another. Using the information listed above, does Earth stay the same distance from the sun throughout the year? If not, what month or months and during which season for the northern hemisphere is Earth closest to the sun, furthest from the sun? So know that distance is obviously changing because those numbers are different. And then we are closest in December, and that is winter. Brr. Furthest away, so tallest of allest, is in June. And that is summer. Would you say the temperature stays approximately the same every month of the year, your location? No. Big fat no. Are the seasons, summer or winter, the same in the northern and southern hemispheres at the same time? When it is summer in the northern hemisphere, what season is it? When it is summer in the northern hemisphere, what season is it in the southern hemisphere? So no. Seasons are not the same in the north and the south. And when it is summer in the northern hemisphere, it is winter in the southern hemisphere. All right. So we have our 2 students having their little Galilean style debate. Consider the following discussion between 2 students about the cause of the seasons. So it's the reason for seasons. Student 1, I know that it's hotter in the summer, good. Colder in the winter, good. So we must be closer to the sun in the summer than in the winter. Student 2, I disagree. Although the distance between Earth and sun does change throughout the year, I don't believe that the seasons and changes in Earth's surface temperature are caused by the distance between the sun and Earth. If the seasons were due to the sun-Earth distance, then both hemispheres of Earth would have the same seasons at the same time. All right, do you agree or disagree with either or both of the students? Student 1 is incorrect. We are not closer in summer than we are in winter. And student 2, at least so far, everything student 2 has said is correct. All right. At different times of the year, locations in the northern hemisphere can be a few thousand kilometers closer to or farther from the sun than locations that are at the same latitude in the southern hemisphere. So as shown in the drawing below. However, the distance between the Earth and the sun is on average about 150 million kilometers, we saw from the previous table. So there's our happy sun. And so, obviously, drawing not to scale, 150 million kilometers, and the part in the northern hemisphere that is now tilted towards the sun, that is a little bit closer than the same latitude in the southern hemisphere that is tilted away. That is a fraction of the radius of the Earth. The radius of the Earth is about 6,000 kilometers, and we're talking about an overall distance of 150 million kilometers. Question 6. Do you think these differences in distance between locations at the same latitude in the northern and southern hemispheres are the cause of the seasons? Explain your reasoning. And let's go to question 6, where they're debating that. Student 1, I get it. So, since Earth is tilted, there are times when the northern part of Earth is closer to the sun than the southern part. So the north has summer and the south has winter. And then later, the south is tilted towards the sun and gets closer and has summer. Student 2, I disagree. Although the tilt does bring one hemisphere closer to the sun, the difference in distance between the northern half and the southern half of Earth is really small compared to how far away Earth is from the sun. So do you agree or disagree with either or both of those students? So again, student 2 is on it today. Everything student 2 has said is correct. Student 1 is correct about it being tilted, but that small change in distance is not what's causing your difference in seasonal temperatures. So no. And if we go back to just look at how the distance is varying because of our orbit, we're talking about the tilt causing something of order, say 1,000 kilometers difference, and we're talking about variations here that are in the millions of kilometers place. Okay. 1,000 is much less than a million. So it is not that the tilt of the Earth is giving you a difference in distance that is causing the seasons. So let's think about what is happening because of the tilt of the Earth. So we're going to talk about direct light and tilt. Consider the picture above in which two spotlights, spotlight A and spotlight B, are shown casting light onto a screen. Note, each spotlight gives off the same total amount of light. All right. Which of the two lighted areas, the one created by spotlight A or B, would appear brighter? That is going to be A. It's sunlight, or not sunlight. The spotlight is more concentrated. It's in a smaller area. Which of the two lighted areas is smaller? A. Which of the two lighted areas receives more direct light? The amount of energy on each unit of area from the spotlight. That is again A. If a thermometer were placed in each of the lighted areas, which one would read the higher temperature? There is greater intensity of light at A than there is at is a greater inflow of energy at A than at B, and that would be also reflected in the temperature. Which of the two positions would be similar to the way that sunlight would shine on the southern hemisphere of Earth during winter in the southern hemisphere? Explain your reasoning. Well, that would be spotlight B. I have light from spotlight B is spread out over a larger area. It is less direct. So even though the intensity of both spotlights is the same, as it falls on the screen, there is less energy coming in over that area where spotlight B is shining. And that is like the southern hemisphere in winter. All right. We got our sun again. Consider the picture below illustrating 3 different regions of Earth, the northern hemisphere, the southern hemisphere, and the equatorial region at 2 different times of the year, 6 months apart. So at point A, B, C, D, E, F. Now, note, the drawing is not to scale. In fact, you could fit more than 100 suns between the sun and the Earth. You can fit 110. I already worked that out. Alright, so which of the locations A through F corresponds with summer in the northern hemisphere? Explain your reasoning. So, summer in the northern hemisphere would be when the northern hemisphere is receiving more direct sunlight. And the way I sort of try to look at this is think about what's happening at the poles. So let's start over here. Location A, up near the pole, that's actually in complete darkness for an entire day. As the Earth is spinning around on its axis, the sun actually never rises. That cannot possibly be summer. The sun never coming up is going to make it very, 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 very cold. So this has got to be northern winter. When it's northern winter, it's southern summer. And we can check that out because if I think about Antarctica, at this position in Earth's orbit around the sun never sets. It never sets below the horizon as Earth spins on its axis. So northern winter corresponds to southern summer. And over here, I have southern winter, because Antarctica is in complete darkness for an entire day, corresponding with northern summer. The Arctic is in complete daylight, 24 hours a day. So, which of the locations corresponds with summer in the northern hemisphere? D. Why? It is getting more direct sunlight and a longer duration of sunlight. Which locations, A through F, corresponds with winter in the southern hemisphere? Explain your reasoning. So, F is winter in the southern hemisphere. The sun is lower in the sky, less direct sunlight, and a shorter duration of sunlight. Okay. During which season, summer or winter, is the number of daylight hours the greatest? During which season, summer or winter, is the sun highest in the sky at noon? Again, summer. How are your answers to the previous 2 questions related to the time of year that your location experiences the highest average temperature? Well, they are the same. Not a quinky dink. How would the number of hours of sunlight and the height of the sun in the sky at noon change, if at all, over the course of the year for locations on the equator? Explain your reasoning. So if I'm at the equator, the sun is actually going to be directly overhead at the equinoxes. If you think about it. And it's going to be lowest in the sky at our two solstices. Ugh. All right. Applying the model of causes of seasons. If somehow the number of daylight hours did not change throughout the year, but Earth was still tilted at 23.5 degrees, would there still be seasons in the northern and southern hemispheres of the Earth? Would the temperature difference between the seasons still be as great? Explain your reasoning. So if you could somehow change it so the number of daylight hours were fixed, but Earth were still tilted, yes, there still would be seasons. So this is our spotlight effect. With the sun higher in the sky in the season that's summer, you still get more energy input because you have more direct light. Would the temperature difference between the seasons still be as great? No. The variation would be smaller. And that's what seasons are. It's not about what the average temperature is. Seasons are about how the average temperature varies over the course of a year. If the northern hemisphere were tilted 90 degrees towards the sun, which location would be warmer in summer, Arctic Circle or Florida? And that would be the Arctic Circle. More direct light and the sun up for 24 hours a day. Provide two pieces of evidence to support the fact that the varying distance between the sun and Earth cannot account for the seasons. So, a couple things you could name. We are furthest from the sun in northern winter, and if it were just a varying distance, we also have the observed fact that we have opposite seasons, so different seasons in the different hemispheres. Okay, which two things are most directly responsible for the cause of the seasons on Earth? Height of sun in the sky, and that gives us more direct light, so that was the spotlight effect, and the duration of daylight. If the sun is above the horizon for a longer period of time, you have more input of energy from the sun. So that is the reason for seasons. For us here on Earth, seasons are not caused by variation in distance. We have a fairly circular orbit, and we are in fact closest to the sun in northern winter. That moderates our seasons. It is not causing our seasons. Cause of the seasons are twofold. How much direct sunlight do you get, which is how high is the sun in the sky, and what is the duration of